things. Alright, we're going to work on section 6.2, exponential functions and their derivatives. So, exponential properties. Let's start with the properties of exponents. So number one says a to the x plus y equals a to the x times a to the y. So you can distribute your exponents. That's what that means. A to the x minus y is a to the x divided by a to the y. A to the x to the y is a to the xy. Multiply your exponents. And ab to the x is equal to a to the x b to the x. Alright, and the second part we're going to look at is we're going to look at the limits of exponential functions. So number one says, if a is greater than 1, then the limit as x approaches infinity of a of x is equal to infinity, and the limit as x approaches negative infinity of a of x is equal to 0. If a is in between 0 and 1, so a fraction or a decimal, then the limit as x approaches infinity of a to the x is 0, and the limit as x approaches negative infinity a to the x is infinity. So your limit depends on your base. Alright, so let's look at actually finding then some limits of exponential functions. So an example, when I'm given the limit as x approaches infinity of 2 to the negative x minus 1. First thing I know I can do is distribute my limit. So I'm going to end up with the limit as x approaches infinity of 2 to the negative x minus the limit as x approaches infinity of 1. Then if I keep manipulating this function so I have a positive exponent, the limit as x approaches infinity of 1 over 2 to the x. In order to make that x positive, I need to move it to the bottom of a fraction. And what is the limit as x approaches infinity of 1? The limit as x approaches infinity of 1, if I want to simplify it. What is that? 1, yep. If we remember our limit laws, the limit of any constant just remains that constant. So the limit as x approaches infinity of 1 is just 1. Then, because I need to figure out what my base is in order for me to solve this limit, I'm going to pull my 1/2 out and just put the exponent on the outside. So I end up with the limit as x approaches infinity of 1/2 to the x minus 1. So now I can use my limit laws to make a be the 1/2. And so if we look at rule number 2, when our a is in between 0 and 1, which 1/2 is in between 0 and 1, what is the limit as x approaches infinity? 0. Okay, so I know that the limit as x approaches infinity of 1/2 to the x is 0. So I end up with 0 minus 1, which is negative 1. So my limit of 2 to the negative x minus 1 is negative 1. So let's do the same thing for example 2. Given the limit as x approaches infinity of 5x plus 1, and the limit as x approaches negative infinity of 5x plus 1. First thing I'm going to do is I'm going to distribute my limit. So limit as x approaches infinity of 5x plus the limit as x approaches infinity of 1. Well, what is the limit as x approaches infinity of 5x? If I let 5 be my base. Look at rule number 1 for your limit rules for exponential functions. Since a is greater than 1, right, because 5 is bigger than 1, what is my limit as x approaches infinity? Infinity, right? Okay, so this becomes infinity. And what's the limit as x approaches infinity of 1? 1, yep. And infinity plus 1 is infinity. So I do the same thing then for the second one and distribute my limit. I get the limit as x approaches negative infinity of 5x plus the limit as x approaches negative infinity of 1. So still using rule number 1 because 5 is greater than 1. What is my limit as x approaches negative infinity then of 5 to the x? 0. Okay. And my limit as x approaches negative infinity of 1. And 0 plus 1 is 1. Okay, so when you're looking at the limits of exponential functions, when you're simplifying them, you're always either going to get infinity or 0 to be the simplification part of the exponential function. Second part of what we're looking at is one of our new numbers that we probably haven't dealt with much in math, which is e. E is kind of like pi, in that it's an irrational number that goes on forever and ever and ever and ever, except that e is equal to 2.71, 8281, 828, etc., etc. And then the limit as h approaches 0 of e to the h minus 1 over h is always 1. And the derivative of e to any exponent is just e to that exponent. Right, and then we'll look at the chain rule version of the derivative of e to the x. So if we let u be our x for our chain rule, then the derivative of e to the u is equal to e to the u times the derivative of u. And the integral of e to the x dx is e to the x plus c. Alright, so let's look at putting some of these to uses then. So if I look at example 2, I'm given y equals e to the tangent of x, and I'm asked to find dy dx. I'm asked to find my derivative of y in terms of x. So I'm going to use my chain rule, which says that my derivative of e to the u is e to the u times the derivative of u. So in order to make that true, I'm going to let u equal tangent of x. So then this would become the derivative of d to the x e to the u. and I know that then e to the u stays the same, and then I need to find my derivative of u. And since u is equal to tangent of x, what's the derivative of tangent? If we go back to all of our derivative rules, we have a whole table of them. Derivative of tangent is secant squared. So I know that the du dx becomes secant squared of x. And then if I just re-replace my u with what it equaled, I get e to the tangent of x, secant squared of x. That's it. So the derivative of e to the tangent of x is e to the tangent of x times secant squared x. Let's do another one. So example 3 gives me y equals e to the negative 4x times cosine of 5x, and I need to find my derivative. I'm going to need to use a couple different rules to find this. So the first thing I'm going to do is I'm going to think way back to my chain rule, and I'm going to let f of x equal e to the negative 4x and g of x equal cosine of 5x. And then the chain rule was first times the derivative of the second plus the second times the derivative of the first. So I need to find my derivative of g of x and my derivative of f of x. If I start by plugging stuff in, f of x is e to the negative 4x. What's the derivative of cosine of 5x? Derivative of cosine of 5x. What's the derivative of cosine? Let's start with that. Sine. Okay. So the derivative of cosine of 5x would be sine of 5x times the derivative of the inside. So what's the derivative of 5x?
5x.
Derivative, not inverse. 5, right? Derivative of 5x is just 5. Then I need to take my second, which is just cosine of 5x, so that stays the same, times my derivative of my first. So e to the negative 4x derives to be e to the negative 4x, and then we need to take the derivative of negative 4x, which is negative 4, right? The derivative of negative 4x is negative 4. So then let's just simplify. So this becomes 5e to the negative 4x sine of 5x plus, nope, not plus, okay, minus 4e to the negative 4x cosine of 5x. Okay, so lots of different rules in play for the derivative of that one. Any questions? All right, and then the next example I'm going to look at is example 8, where I'm going to find the integral of x squared x e to the x cubed. First thing I'm going to do is I'm going to let u equal x cubed so that I can integrate e to the u, which tells me then that du is equal to, what's my derivative of x cubed? derivative. 3x squared, yes. Okay, and so I have an x squared in my problem, I don't have a 3 in my problem, so I need to add a 3 and add a 1/3 outside. So if I replace everything with my new stuff, my 1/3 stays out front, the integral 3x squared is replaced by du, and e to the x cubed becomes e to the u. And what is the integral of e to the u? Or e to the x? Or e to the anything? It's just the same, right? It just stays the same. So this will become e to the u plus c. And then if we replace our u is x cubed. So this becomes 1/3 e to the x cubed plus c. Okay, so fun stuff today with all of our new letters. So page 401, 23 through 49 odd, 79 through 89 odd.